give the floor to the climate professionals.
Yeah, so today I'm here together with Paul. He is online. He is the KNMI developer. And we would like to give you a short introduction on the climate work package, and then Paul will give a demo of the operational climate API from the Netherlands. So this is a schema that he started with, and this was presented also yesterday rather swiftly. So maybe I want to give a bit more overview on it. That I would like to make sure that you know that we are together with 9 countries, and we all develop a very similar EDR with the MeteoGate protocol, as we call it now, apparently. The developers within our work package, they're also in the profile work together, so the observations and the climate can follow the same schemes. All these different APIs, they will be grouped together in the climate API aggregator, and this aggregator will be operated at the KNMI, and also, well, so not at the KNMI, so we use the AWS platform and not the European Weather Cloud. Maybe that's a little bit different from all the other work packages. And then, as you can see here in the scheme, MeteoGate will provide a user interface. It's quite clear, of course, that so you will be able to query for data over certain areas within Europe. And yeah, there are a lot of gaps here. Maybe the countries that are taking part are more gappy than the countries that are not participating. But for this, KNMI is maintaining the European Climate Assessment and Datasets. In the European Climate Assessment and Dataset, we have 25,000 stations from all of Europe, and we maintain this as the climate node for the Regional Climate Center from the WMO. So it's one of our tasks to gather this climate data. Yeah, as a little bit of background, we maintained this for 25 years. However, some of these data that is shared with us is sent with text files via email, and we don't think that that really is the future. So that is why we really wanted to participate in this initiative to make this more ready for the future. But we hope that more countries will participate, and that's why it's really great that there are so many others here interested in our initiative. And I also want to highlight another advantage of the Rodeo infrastructure, IT infrastructure, is that the European Climate Assessment and Dataset, they only have daily climate data, while hourly and sub-hourly data is not shared with us in this way. And since we started 25 years ago with this database, then yeah, daily data was just great. But these days, of course, we would like to have higher volume of data. So this is also a step towards a better way of sharing climate data. And this will also influence the way that we can do our climate analysis. So that's why it's very important to do all this together. So in May last year, we published a document in which we presented this design, how the API network would look like. So on the right hand, you have your customer, and you will be able to search in the discovery catalog that we have now seen, also in the MeteoGate. This is connected to the WIS2 broker. And also in the climate work package, we will implement the MQTT broker, because this is a requirement for sharing our data. But this MQTT broker is only on the discovery metadata and not on the data itself. So what this implicates that might there be an update in the data itself, you will not get a message though. Then once you ask for data, you will go through the climate API aggregator that's here at the bottom. We changed the name throughout the project, and then with the OGC EDR API, we'll be able to retrieve the data. So within this PowerPoint, I included the documents, so you can want to share the PowerPoint afterwards. You can read a bit more what choices we made and maybe also why. And also the discovery metadata, what we discussed yesterday. It has an example with it in the WCMP standard. But yeah, we also find out, of course, that this has to be updated. We did this the update last time, like 9 months ago, but we will update this also so that we can also pass the test yesterday that I think we won't yet. But so we will work on this, and then we can distribute, continue to distribute this. So within the climate work package, we will focus on just a few climate parameters. I would like to maybe read them out loud though. So we go for the wind direction and wind speed, the temperature, the mean, minimum, and max, radiation, precipitation, pressure, and humidity. This also indicates that likely your countries have different climate parameters. So may you want to be compliant, of course, to the HVD regulations. Those cannot be connected to the aggregator, but you have to connect them through MeteoGate directly. The reason why, well, we choose those 4 parameters because these might be most important for climate analysis, and within other, and we want to have like a small subset, so it wouldn't be, yeah, so that it would be overseeable what can be done. But maybe in the future we can extend the number of 4 parameters, but at least this was our start.
Yeah.
Yeah. So what we see here in the scheme is that all NMHSs, they still have some freedom in, for instance, the description of the parameter, and also the ID that your time series can be called. And we thought that that would be really important because if you start renaming all your time series, maybe at one point they get lost. So in this way, you can still name the time series the way that you're used to, but then you include extra names. So the extra names that are fixed are, for instance, the CF convention standard name. That's here in the middle, and also the level of and a label is fixed, and then there is still some freedom. It's of course also important to include the level in which there would also be possibility to query on different levels. And you have to indicate, of course, if your time series are in an hourly fashion or in a daily fashion for the climate parameters. I think, well, of course, you're also free to share monthly or yearly data in the same fashion, but these are also not connected to the aggregator. So yeah, it's just that this is our focus, this is what we all do. So a little bit further on the climate aggregator. So the aggregator unified the multiple EDR APIs. And so this is merging all the different collections. You have also the opportunity within the climate aggregator to choose as a user the output that you want. Because in the climate world, we work more often with the NetCDF, and so therefore it is important that this can also be served in a format that is used by climate scientists and others, and not only in corporation. So the benefits for NMHS to actually work together within this work package is that it really, the aggregator, if you connect to the aggregator, it really simplifies your EDR implementation. And well, you still have your own flexibility. And for the users, we create, of course, now one endpoint for all climate data within Europe. Yeah. So there is a documentation for developers if you want to make something similar like we do. So, well, thank you, Harvard, this morning for introducing the EDR profile. So if you follow this profile, it will be very relatively easy to connect to the aggregator. In addition to this, we developed a workshop on how to make your own API from scratch. We gave this workshop for the non-Rodeo members in Vienna, and all your institutes here in the room, they actually participated if they were non-Rodeo, so this is great. And I saw that from Slovakia we have someone online, and you did not participate in the workshop, so I would really like Marianne to invite you to come to the workshop in Zagreb on the 8th and 9th of October. So in the workshop there were 9 other countries, so non-Rodeo countries that participated, which indicates that of all EUMETNET members, only 14 did not participate, of which some are also non-EU members. And so it's not clear if they will immediately follow the path that we do. So what I would like to say with that is that we really think that a large body of countries may be interested to implement, to share climate data in the same way. So then we also will develop a user documentation, and this was also just shown by Tim actually, because of course it's all rather similar. So at the KNMI data platform we have EDR documentation, and within our work package we will add a bit more on this. For instance, also you from Norway wanted to contribute to that, but I think this is a starting point for the user documentation within our work package. Yeah, then I would like to ask Paul, who is online, to give a demo of the climate EDR from KNMI.
Yeah, can you hear me?
Yeah, very clearly.
Yeah, okay, cool. I'll take off the screen. Let's see. I hope you're seeing the KNMI developer portal at the moment on your screen.
A little bit pixeled.
Sorry?
It's like it's way pixelated just at the moment. It's like you're trying to show us something illegal.
You can't read anything.
Redacted.
Is it still?
Switch off your camera.
Yeah, it's still.
Let me see if I reshare if it becomes any better.
Yeah, you can't buy it anymore.
How about now?
Yeah.
All right, cool. Yeah, so I'll give a little demo on what we've done for the climate EDR that we've developed. Maybe what's good to know is that what I'll be demoing is the KNMI climate EDR. And also part of the aggregator functionality, but not so much the aggregator functionality in where it already combines multiple countries. So you'll be viewing the KNMI EDR through the aggregator, but so part of the aggregator functionality is working, but the summarizing of the multiple countries, that's a part that's not been implemented yet. That's work in progress. So of course, the previous later presentation you already saw the developer portal, so next to the OpenNet API, there's also the EDR API, and also here, similar to the OpenNet API, you'll need an API token, and which you can request here in the API catalog. So you can request your API key here. What's interesting is to switch to the technical documentation, so the Swagger documentation, and sorry, misclicked there. So I'll have to. No, I'm still logged in. Okay, so what you see here is the KNMI EDR API, and what you'll see is that we have actually already multiple collections available in there. So there's our old 10-minute observation collection there, and there's a couple of other collections which I won't really go into detail today. And then there's our new climate data set. So there's a daily observation data set, an hourly observation data set, and there's our new 10-minute observation data set. And so I'll open the daily data set and to ask for the collection metadata. So the overall metadata of the collection. And what you'll see is that so we've got data in this collection from 1901 till the, let's see, yesterday or today. Yeah, actually yesterday. So it's the end of the interval. So it's yesterday, the date of yesterday. And so this is data for the whole of the Netherlands. And then within the metadata, you can see these custom dimensions. This is something that I'll explain a bit later, but what I want to show right now is scroll down to the queries which are available, so which are also demo later, but I want to focus on is the parameter metadata. So Marlies explained just now in her presentation, she showed the table, and this is how it actually looks in the metadata. Or is it, by the way, should I make the font bigger? Is it readable?
If we're
Bit
close.
small.
Let's see.
If you get rid of the chat,
Okay.
then that will make it a bit bigger as well.
Okay, so I'll focus here, for example, on the mean wind speed. So this is a parameter called FG, and then you see the label, you see the description. So the description is the human readable version of this metadata. You see the data type, so it's a float, and then the unit meters per second, and then it's also annotated with this with the cute vocabulary. And then the observed property, which specifies the CF convention, the climate forecasting convention standard name, so it's the wind speed in this case. And then the aggregation period, the duration, so it's aggregated over a day, and it's the mean wind speed, so the aggregation method is mean. And then the height of which this measurement was taken, so it was taken, it's been recalculated to 10 meters in this case, but it's 10 meters above the ground being measured. And again, this EUMETNET standard name, and I understand that there's a bit of discussion that this should maybe be called MetOcean at some point, but that's something we haven't done yet. So the standard name is repeated here again. So yeah, that's the collection metadata. And so what our API is doing is providing a lot more parameters than just the core parameters. So there's a whole list of parameters which is in this collection. Next thing I'll do is quickly show you if I query the locations, then you can see which stations are available. So I'll copy this output that you get. I'll copy to the GeoJSON playground, and there you see that we've got stations from the Caribbean Netherlands, the islands there, but we mostly got the station from the Netherlands, and also the platforms which are located on the North Sea in these data sets. Although, of course, for the climate data.
Oh,
Sorry?
there will be a question? There's a question.
Sure, go ahead. I don't see the questions.
Can we merge with my request from the morning part to, can I filter, for instance, those locations that only, for instance, measure the wind at 10 meters, or we can randomly choose some other parameters, but let's simulate me being interested only in a subset of the data. I wanna get some intuition on the EDR usage as well.
You're breaking up a little bit, so I can't completely hear you. I think your question was, is the question which parameters are available per station?
No, like now we are browsing through locations, and let's assume that I'm only interested in the ones measuring wind speed.
Yeah. Yeah, so that our EDR doesn't provide that functionality at the moment. So the EDR spec is does not really offer that possibility, but I know that the ASO EDR API has implemented this, where you have an extra query parameter where you specify the parameter names, and then you can query if a station has a certain parameter.
So
But
I would
we
need
haven't-
to, like, on the client side, filter out, like, retrieve the whole list and then further filter on the client side.
Yes. But isn't it, since so,
You can filter.
not here.
Okay, I see.
Yeah, so that hasn't been implemented here. It's on our wish list to do something like that, but we haven't done that just yet.
Will you find observations that's not standard height?
Yeah, so not.
Climate stations, and then the standard height is 10 meters for wind. So when you have 10 meters for wind and 2 meters for a lot of other parameters. So that's defined as climate stations and the high level demo stations. So but for ESO, we have implemented more search policy.
Yeah, sorry.
Yeah. Sorry, I have a bit of trouble following the discussion in the room, but I'll try to follow it. I'll continue with the demo if that's okay.
Yes, please. Thank you.
So the next thing I want to do is actually query for some data. So I'll pick an area, query endpoint, and the nice thing about that is that you can enter a polygon. So what I'll do is I've drawn here this polygon of the Netherlands, and I've got this WKT polygon description, which I can input here. So I'll put that here, and then I'll put the date time range, and I'll prepare this date time range here. So I'll query a couple of days in 2022, and what I'll query for is a PG, which is the pressure. It means sea level. So I'll do an execute, and you get back a coverage JSON with multiple stations in there, and then you can put that into the coverage JSON playground, and you see that we've got only these queries in this polygon, only this station in this polygon, and I can pick one, and you see the air pressure displayed there, and the values are here. So the other thing what I want to focus on is what's also possible is to further query and use the custom dimension, so the method, the duration, and the standard name. And the way that you can use this, it's also important for the functionality of the aggregator and for climate series in general, is that so let's say we got going to query a single location, so querying Amsterdam in this case, so Schiphol Airport, and I want the air temperature. So I'll query for the standard name on that, and I want the duration. I want just the maximum air temperature. Into method, and I want this at 1.5 meter height in this case. And then I execute my query, and what you see is that you get just a single parameter back. So it's maybe a bit hard to see here. So what I'll do is I'll put in just increase the time range here to make the output a bit more interesting. Copy the coverage JSON output and put it into here. So I've got this single station here, and you see that I've got the maximum air temperature. And just to show you the parameters, you see TX, which is the maximum air temperature in there. Now, if I would change my query and not include the maximum as method, and use that and query for that, and copy this into the playground, you'll see that I get back 3 parameters. I get the maximum temperature, the minimum temperature, and the mean temperature. So it's also visible here in the data. A maximum, minimum, and mean temperature. And so this is a way that especially if we want to query across multiple countries, you can use these custom dimensions to make these queries easily. And you don't need to know the exact parameter names, but you can use the metadata of the parameters to actually retrieve the parameters that you're looking for. Any questions on this part? If not, I want to switch to, so right now I was using the Swagger API, but I just want to give a small demo of how you could use this in a Jupyter notebook. So I've got this notebook and getting a lot of noise from the room at the moment.
Someone is coming out.
We have quite noisy chairs in the room. So.
Okay. Well, hopefully it improves. So just a small Jupyter notebook where I want to show how you can query at the same time. So as I showed in the beginning, in this EDR API, we've got the 10-minute, the daily, and the hourly data. So I just want to give a small demo of how you can use this. So here in this playbook, I'm querying this couple of days in May of 2017 in the build in Utrecht in the Netherlands.
Maybe you can make it a bit bigger. Paul.
Yeah. How about this?
Thank you.
So I'll query the daily data, and again I'm querying the minimum and the maximum temperature across the day. You get the coverages and you back like this, and I'll do the same with the hourly data. So basically, I just change the collection, and in this case, I have specified the parameter name. So here it was TX, and then here I'm specifying the mean temperature across the hour. So this is the mean temperature across those hours, which is actually, by the way, maybe if you're confused, that's the past 1 minute air temperature. That's the way that the hourly data is made for KMI for the air temperature. Then the 10-minute data, which is 10-minute intervals for the same day time period, and then I can nicely put this into pandas quite quickly. You get these put it into tables, and with those tables I can also plot that. So I've now plotted the 10-minute in blue, the hourly data in orange, and the minimum and maximum temperature in green and red, and maybe the minimum is at the hourly data is at the end of the day, so that's why you see it here at the red and green dots at the end of the day. But I hope you can appreciate the granularity of the 10-minute data, of the hourly data, and then of the daily data. And then doing something like this. So here I'm just querying all the data for a whole year. So the daily data for the whole 2022-24, and then the maximum air temperature. Put that into a table. You get the whole year, and you can quite quickly get the maximum air temperature for a day, and also the date on which this occurred. Just a quick demo of how you can quite easily get graphs and information from an EDR API. So that sort of concludes my my demo. I'm wondering if there are any questions, or if there's any question about the functionality of the aggregator, or anything else that you would like to have clarified.
Yeah, I of course got questions.
Maybe you have many. You can maybe.
No, it's one, but I hope I can still speak loud enough.
Sure.
So you guys have done a great job developing your own standalone EDR compliant API, and helping grasp those concepts. In what way are you now pumping this data into the MeteoGate? At which point does this become a one-stop shop for some user who is not aware of this API? And it's probably not done through the ESOC, but it's on. Is it done via these brokers that we we were learning yesterday about, or can you explain this interplay between those entities?
Elise, will you take this? I can also take it, whatever you prefer.
So I think we will do two things. So like what we did yesterday, for all the different APIs, we will also include all the discovery metadata in the MeteoGate catalog. So then you will be able to find all the different APIs within MeteoGate. And then, so all the functionality that you see now only for the Dutch data will be rather similar for the aggregator, but then all these data will be included with all the different APIs. Yeah, and then that will also have one discovery metadata input in MeteoGate. So you have, yeah.
Okay.
So the loop is, you may have eight
to the
matrices.
Willie is talking now.
Their data will go into the aggregator. The aggregator will provide that data to the user via MeteoGate, aggregating the data and sending it in a better, more kind of slightly more user-friendly format. So,
And this will all be done on the just metadata capabilities layer. So just by specifying this metadata JSONs, each of the local agencies will advertise what they have, and everything will be done automatically.
I don't know if this is automatically, and that's for Jeremy.
Nothing is automatic.
I think MeteoGate is
My brain is melting at the moment.
yeah. I think also MeteoGate is a place where you can advertise your data sets, right? So then from the advertising, you can go to the local endpoint. Yeah.
So yesterday we were writing some discovery metadata for a data set that you can publish, and that discovery metadata goes into the catalog. You can browse the catalog, find the endpoints. There would be a data set, a metadata record describing the aggregated set of hourly climate stuff and another one for daily climate stuff. If you wanted to expose your Slovenian national set, there would be you could do that separately, and the links in the metadata would point you to the EDR endpoint for your national stuff. All of that is possible. With data, it kind of begins with the discovery process.
Okay, so the discovery is still, at the end of the day, it's going to be made by human researchers. For instance, it will just be a common place where you get to see like additional links, and where you will be able to find the Danish API.
Yes.
And then
Yeah. So one of the things that we wanted the Data Explorer to do was allow us to a human to search with text or filters or map or whatever, preview some data sets, see if they're interesting, and if they are, then we'd be able to get the URL for the service endpoint that you can then copy into your other system, your operational system, or whatever, right?
Okay. So it's not making the local APIs transparent to the end user. It's just pointing to, but it's just advertising what is there at all.
And I think it won't be long, he says, in inverted commas, before ChatGPT or Claude can browse the catalog and then figure out the calls to make on your behalf, right? Honestly, it feels possible to me.
Okay, I see.
But right now, advertise the data in a discovery metadata record that get published in the catalog, and then from there you can find the different endpoints.
But for instance, the Danish data won't be additionally pumped into the ESA just for the sake of actually having data available through this platform too. It's if you wanted to do that, you would need to pretty much establish a parallel system for loading this. It's not that ESO could just automatically attach to the existing local APIs done in the.
So one important issue with ESO is that it's 24 hours for data. But all the countries in Europe should probably have some API with open data, which is compliant with the EDR profile that we have talked earlier today. And that all those APIs could either be addressed by the aggregator, or it could be shown but for these 9 parameters or something. Yeah. But you could also point MeteoGate to your local API. So for example, the Danish API could show all the data, but the automatic aggregator could be showing these climate variables. And I'm not sure if you have this, but I think you have.
Yeah, no, we have separate APIs and separate data sets. Yeah.
But
ESO serves observation data, and this is climate. This is slightly different.
Climate is also observation.
Okay.
So,
yeah, thanks for that.
And the clear difference between the ESO and the climate is that ESO, they have like 24 hours data only. So then this is stored within a cache, while the climate data has the aggregator. So this is so the data is stored locally by the data provider, and then the full set.
the Met industry has several ways and methods.
Paul, did you want to add something?
No, I think that I just had the same remark that Vega had about the ESO being 24 hours and this being a longer time period.
I have a question. So let's say I made an API that is ready for the aggregator. How does the aggregator pick it up? Is it through the discovery metadata record where it gets picked up and integrated, or do I send an email to KNMI?
No, I think then we have to get get together how to integrate the API to the aggregator, and that has to be but we didn't do this yet. But it will be rather similar to what we did with the subsets. So, but I think like when you comply to the profile, this should be rather straightforward, but it needs some work. Yeah.
Okay.
But since the aggregator is not finished yet, we don't know how long and how much effort it would take.
Okay. Right.
Okay, maybe, what else can you expect from us? So we're still working on the aggregator, and we hope that the aggregator will be available through MeteoGate also in Q4 2025, so this year. And then, please, if you have not been to the workshop to make your own EDR API, feel invited and come, or maybe you have been to the workshop in an online fashion and maybe you want to have a bit more interaction. Maybe you would want to send someone else to be in Zagreb on site. So that's also another possibility. And we would also like to make sure that within this year, in 2025, we will only onboard the Rodeo partners, so the 9 partners. This will be enough work for us. And only in the new year, from 2026, we may be able to connect other countries. Yeah, however, maybe we would like to share the slightest note that there is no funding for after 2026 to keep the aggregator up and running, but we are invited by the EUMETNET Assembly to make a proposal for continuation. And we also speak with Copernicus maybe for some additional funding, or maybe we can get some funding somewhere else. But that is a slight note, I guess. And if there are more questions, please share it with us.